Hey everyone. So this next lesson is on parallel lines and proportional parts. So there are four different things we're going to talk about. Two of them are kind of the same. So I guess really three main rules we're going to talk about. So the first one is called the triangle proportionality theorem. And I filled in the blanks already just to save some time, but it basically says if a line is parallel to one side of a triangle, so see how this line here, EF, is parallel to this triangle, and intersects the other two sides in two distinct points. So it intersects this side here at F and this side here at E. Then it separates these sides into segments of proportional lengths. So basically what this theorem says, is since this EF is parallel to CB, and I know that they're parallel because of these arrows. So since those are parallel, it cuts the side lengths into 1, 2, 3, 4 segments that are proportional. So we can use those and write a proportion. So you can set it up in many different ways. Like you could do like this to this equals this to this, or you could do like this to this equals this to this. There's a lot of different ways to set it up as long as you go like the ones that are like opposite each other go together. So here's one proportion you could write. X plus 22 over 18 equals x plus 2 over 6. And then remember you would cross multiply. So you're going to have 6 and then x plus 22 equals 18 and then x plus 2. And then you're just going to distribute. So we're going to have 6x plus, and then 22 times 6 is 132. And then 18x plus 36. So then to solve for x, I'm going to subtract 36. So that's going to be 96. Whoops. And then subtract 6x. So that's going to be 12x. So then you're going to get x is 8 here. Okay. The next theorem says that a segment whose endpoints are the midpoints of two sides of a triangle is parallel to the third side of the triangle, and its length is 1/2 the length of the third side. So that segment is called a midsegment. So that's why this is called the midsegment theorem. And so let's look at this picture here. See this segment right here, CD. CD is a midsegment, and I know it's a midsegment because its endpoints, C and D, are the midpoints of the sides of the triangle. See how AC is marked as congruent to CE? So that means C is the midpoint of AE. Then see how BD and DE are congruent? That means D is the midpoint of BE. So basically, we can determine that that's a midsegment based on the picture. And so that means that CD is 1/2 the length of AB. It's also parallel. So if we look at the given information, let's do x first. So we have x plus 12 up here, and we have 5x minus 3 here. So since CD is 1/2 of AB, that means 2 of them would equal 1 of AB, right? That's probably how I would set this up. I would do 2 times x, 5x minus 3 equals x plus 12. And so then that's 10x minus 6 equals x plus 12. And then just solve. So I'm going to add 6, subtract x. So we have 9x equals 18, and then x is 2. Okay, so that's how we would solve for x. Let's take a look at what we would do for y. So we're given that this one is y plus 8. This one is 5y minus 8. So those are just equal to each other. That one's pretty simple. So you would just do y plus 8 equals 5y minus 8. So I would add 8 to both sides, subtract y. So we're going to have 16 equals 4y. So y is 4. So that's the midsegment theorem. If you have a midsegment, it's 1/2 the length of the side that it's parallel to. Okay, the next one is kind of similar to the first one. triangle proportionality. It's just not in triangles. So it basically says if you have three or more parallel lines cut by transversals, the transversals are cut proportionally. So that just means that the four segments, these 1, 2, 3, 4, are proportional. And also like this whole thing, like both of them together, is proportional to these two together. So an example like this, you do actually have to use the big ones because they didn't give us either of these little ones here on this side. Even though this one's 5, they gave us this whole thing is 11, so we know this is 6, but we don't know either of these. So what we're going to have to do is we're going to have to set up x and 6 go together, and then 22 and 11 would go together. So you could do x to 6 equals 22 to 11, and then cross multiply. 11x equals 132, those two. So then x is 12, which some of you may have noticed in the first step because 22 is double 11, so then x would be double 6. Okay, the next one has to do with, again, parallel lines. It says if 3 or more parallel lines, so see how this is parallel to this is parallel to this, cut off congruent segments on one transversal. So see how on this transversal, whoa, see how on this transversal, this piece is congruent to this piece. So that means on this side, this one is congruent to this one. So it says if it cuts off congruent segments on one transversal, it cuts off congruent segments on every transversal. So now I can mark those segments as congruent. And again, that's only because these two pieces are equal. If I weren't given that there were any congruent segments, these segments would just be proportional, and you would write a proportion. So for this one, these are equal to each other, but these have an x and a y, which you wouldn't want to write an equation with an x and a y in it. So instead, we're going to set up something with the two equations, the two expressions that have a y in it. So we're going to do 2y plus 2 equals 3y, and then solve. So I'm just going to subtract 2y. So we get 2 equals y, y is 2. And so now to help us find x, if we plug in 2 right here, we can do 2 times 2 plus 4. So that's 4 plus 4. So this is 8. So this segment is 8 and that segment is 8. So now I can just set up 3x minus 1 equals 8 and solve. So add 1. So that's 3x equals 9. So x is 3. So there's our last rule. If you have congruent segments on one side with parallel lines, you have congruent segments on all the sides. So what I would suggest you do now is pause the video and try these 4 problems, and then press play and see if you got them right. I'm just going to go over them now. Okay, so number 1, we have this triangle. So you're going to use triangle proportionality. So 1, 2, 3, 4. Those 4 segments are proportional. Notice they gave us this whole thing is 33. So if I do 33 minus 11, that's going to be 22. So then we can use these 1, 2, 3, 4 pieces in my proportion. So you could do like x over x plus 12 equals 11 over 22. And then cross multiply. So it's going to be 11 and then x plus 12 equals 22x. So that's going to be 11x plus 132 equals 22x. We're going to subtract 11x. So 132 equals 11x, and x is 12. I feel like this number 132 has come up several times throughout this lesson. Okay, here's the next one. So this one is a mid-segment, and I know it's a mid-segment because these endpoints are midpoints of the sides. So that means that x is just half of 32. So you could do it a few different ways. You could do 2x equals, not 32, 35, and then just divide by 2. So x is just 17.5. It's just half of 35. You could even just do it without an equation and just get half of 35. Okay, so this one's kind of like number 1, where we don't have triangles, but we do have parallel lines. So these 4 pieces are proportional. So you could go across like that, or you could do like y to y plus 3, 16 to 32. It doesn't really matter. So how did I do this one? I went that way. All right, so for this one, I'm going to go across. I'm going to do y to 16 equals y plus 3 to 32. And then cross multiply. So we're going to have 32y equals 16y plus 48, because that's 16 times 3. Subtract 16y. So that's 16y equals 48. Y ends up being 3. Okay. Then last one, number 4. This is the one where we have parallel lines. We have congruent segments on this transversal, so that means that these are all equal. All 3 of them are equal. You would not write an equation with all 3 of them, obviously, though. You would just pick any 2 and set up an equation. So I could either do this one equal to this one, I could do this one equal to this one, or I could do x plus 3 equal to 12. I'm going to do 2x minus 6 equal to 12. So you're going to add 6. I guess x plus 3 equals 12 probably would have been the easiest one, but that's okay. So if you add 6, you get 18 here. So x is 9. And I'm not sure why this says find x and y. That must be an error. There is no y here. All right. So that's it. So that is this lesson. Parallel lines, just more writing proportions pretty much. The only time that you're like setting things equal or not writing proportions is for something like 2 and 4. Everything else is proportions. So please let me know if you need some help, and have a great day.